Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to be going over how to calculate the value of the equilibrium constant for a reaction, classify the reaction, and then determine whether the final concentrations of the reaction should be found either by treating it as an equilibrium problem or as a stoichiometry problem. So let's get into this. Okay, so here's the reaction that we have. And so the first thing we need to do is determine what the K value or equilibrium constant is going to be for this reaction. First thing we should notice is that this reaction here is the reverse of a weak base problem, a weak base reacting with water, because if you notice here, we have ammonia, which is a weak base, and you have water. So if we were to reverse this, we would have ammonia reacting with water to produce hydroxide ion and the ammonium ion. So let's go ahead and write that. So we're going to write the reverse. So here we have NH3 ammonia reacting with water. Ammonia is going to take hydrogen from water. You're going to get NH4 plus the ammonium ion plus OH minus hydroxide ion. So now that we've reversed the reaction and we've noticed here that we have a weak base reacting with water, we have a Kb value. So there's a Kb value associated with this reaction. So the Kb value is going to be equal to something. And so the reason we know this has a Kb value is because the equilibrium constant for a base reaction is basically associated with any base, any weak base you have reacting with water. And so in this case, we have ammonia, which is a weak base, reacting with water to produce the products. And so we have a Kb value for this reaction. And it just so happens that we can actually look this Kb value up in a table. So if we look this up, we get 1.8 times 10 to the negative 5. So 1.8 times 10 to the negative 5 is the Kb value for this reaction. Let me just double check to make sure I got that right. 1.8 times 10 to the negative 5, that is correct. Okay, so now that we have the Kb value for this reaction, and as I pointed out early, this is the reverse of this reaction. So if you know the relationships of your equilibrium constant values to the reaction, then you know that anytime that you reverse a reaction, the equilibrium value, the equilibrium constant value will be the reciprocal of the value for the original equation. So here is the equation that we have the Kb value for. This is the one we want to find. So this one is the reverse of this one, which means that the K value here is equal to 1 over the Kb value here. So all we have to do is plug in the value for Kb, which is 1.8 times 10 to the negative 5. And then when we take the reciprocal of that, we get 5.6 times 10 to the 4th. So that is the K value for this given reaction. Okay, well, what about classifying this reaction? Well, if we look at the reactants here, we have ammonium, which is a weak acid. It's the conjugate acid of a weak base, ammonia. So that's a weak acid. And whenever you have hydroxide ion by itself as a reactant, that indicates that we're reacting with a strong base, because strong bases, as you should know, are bases that dissociate completely in water. And so the hydroxide ion will be the only thing that will be of importance to the reaction. The other ion we ignore. So typically, whenever you have a strong base, you can represent it simply by the hydroxide ion. And so this would be a weak acid reacting with a strong base problem. And so what about treating this either as an equilibrium problem or a stoichiometry problem in order to find the final concentrations of things? We look at the K value. So the K value is much, much greater than 1. And so since this is a much greater than 1, that indicates that this reaction highly favors products. And so the equilibrium is going to lie very far to the right here. And so therefore we would treat this as a stoichiometry problem. So that's it for this video. I hope you enjoyed this video. I hope this helped you with this problem and in understanding how to attack these sorts of problems and solve them. If you enjoyed this video, if you like this video, then please by all means like it. Share the video. Hit that like button. Therefore, also make sure you subscribe to my channel. Hit that notification bell up there, and when you do that, click all. And after that, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.